Welcome to the Unit 7 Section 2 video on rational exponents. The radical symbol is used to indicate roots. So we have pieces of our radical symbol here in our notation. The index is a small number to the left of the radical symbol that tells you which root to take. If there is no index, it's understood to be 2 for a square root. If it's 3, it would be a cube root. If it's 4, it would be a fourth root, and so on. And the radicand is the expression under the radical symbol. So in this instance, it's x. The radical symbol is used alone to indicate a square root or with an index to indicate an nth root. So for example, a radical symbol with an index of 3 represents the cube root. Since 2 to the third equals 2 times 2 times 2, which equals 8, the cube root of 8 equals 2. So what does a radical symbol do? It undoes a power. It is the opposite operation of a power. Another way to write nth roots is by using exponents that are fractions. For example, for b is greater than 1, suppose that the square root of b equals b to the k. So let's investigate this. If we square both sides, squaring a square root undoes it, and you get b to the first. We use our power to a power rule to get b to the 2k on the other side. And since we have the same base, then we know that our exponent of 1 on the left side has got to be equal to our exponent of 2k on the right. And then if we divide each side by 2, we get that k equals 1/2. So if you go back to the beginning, we have the square root of b is equal to b to the k. We can now replace k with 1/2. So for all b greater than 1, the square root of b is equal to b to the 1/2. This means that we can take a radical and we can express it as some fractional power. So here's the definition of b to the 1 over n. A number raised to the power of 1 over n is equal to the nth root of that number. So for example, you see that 3 to the 1/2 is the square root of 3. 5 to the 1/4 is the fourth root of 5. 2 to the 1/7 is the seventh root of 2. So for this example, let's convert each to radical form and simplify if possible. So let's start with 8 to the 1/3. 8 to the 1/3 is the same as the cube root of 8, which is equal to 2. X to the 1/3 is the same thing as the cube root of x. The quantity xy to the 1/5 is the same as the fifth root of xy. So you notice that when we have 1 over a denominator, that denominator is your index for your radical. 16y to the 1/2 is the same as the square root of 16y. And we know that the square root of 16 is 4, since 4 times 4 is 16. So we can simplify that to 4 times the square root of y. A fractional exponent can have a number other than 1 in the numerator, as in the expression b to the 2/3. You can write the exponent as a product in two different ways. So b to the 2/3 can be written as b to the 1/3 times 2, because 2 times 1/3 would give you 2/3. So we could write that as b to the 1/3 quantity squared, and we can rewrite b to the 1/3, as we previously learned, as the cube root of b. So we can write it as the cube root of b all squared. But we can also, because of the properties of multiplication, write it as b to the 2 times 1/3, where the 2 comes first. In this case, we would have b squared to the 1/3, so we would have the cube root of b squared. So what this means is that we have two different options in how we can write a fractional exponent. You can write it as the radical to the power, or what's on the inside to the power taken to that radical. So for example, you see there in the middle, 8 to the 2/3 can either be the cube root of 8 quantity squared, or it can be the cube root of 8 squared. In both cases, it will get you to 4 in the end. The cube root of 8 is 2, and 2 squared is 4, or 8 squared is 64, and the cube root of 64 is 4. So you have an option of how you want to write it, and in what order you want to solve it. So let's take a look at an example. Convert each to radical form and simplify if possible. So 8 to the 2/3 we just did. We can write that as the cube root of 8 squared, which is the cube root of 64, which is 4. We have 2x to the 2/3. We can write that as the cube root of the quantity 2x squared, which would be the cube root of 4x squared. When we take 2 squared, you get 4, and then, of course, x to the second power is x squared. For C, we have negative 4xy cubed to the 3/4. So we're going to take the fourth root of 4xy cubed all to the third power, which would give you 64x cubed y to the 9th when you use your product rule or power to a power rule and multiply your exponents. And then for D, we've got 4x to the 4th to the 3/2. So you got the square root of 4x to the 4th taken to the third power. And 4 to the third is 64. X to the 4th taken to the third power, you multiply your exponents. 4 times 3 is 12. And then there's one more step that we can take because 64 is a perfect square. 8 times 8 is 64, so the square root of 64 is 8. You can also take the square root of x to the 12th. The square root of x to the 12th is going to give you x to the 6th, because if you were to square x to the 6th, you would have x to the 6 times 2, which would give you 12. It may be easier to use the properties of exponents to simplify expressions, as you just saw in that last example. So we are going to simplify and assume that all variables represent non-negative numbers. So let's take a look at the cube root of x to the 9th, y to the 3rd. Let's rewrite that in terms of powers. So we know that the cube root is the same as taking everything to the 1/3 power. Now we can use our power to a power rule and multiply our powers. So we've got x to the 9 times 1/3, y to the 3 times 1/3. And that's going to give us x to the 3rd times y to the 1st, which is x to the 3rd y. For this next example, we have x squared, y to the 1/2 to the 4th times the cube root of y to the 3rd. So we've got a lot of simplifying to do here. Let's start by breaking up our pieces. We're going to keep the first piece first. The cube root of y to the 3rd is just going to be y, because the cube root undoes a third power. Now let's break up our x and our y terms in the parentheses and apply our power to a power rule. X to the 2 times 4 gives us x to the 8th. Y to the 1/2 times 4 gives us y squared. And now we're going to use the product rule on y and do y to the 2 plus 1, which gives us y to the 3rd. So our final answer is x to the 8th, y to the 3rd. Again, why do we want to go through all of this? Because x to the 8th times y to the 3rd is much easier to work with in the context of a bigger problem than the mess that we started with.
Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.